Today we are going to perform the impact test on a steel specimen, and as we know that this is the impact testing machine. Okay, this part we can see, this is the dial part. Okay, this is the dial part, this is the needle. Okay, and this dial part goes from 0 to 164 joules. Okay, from 0 to 164 joules. We can see that, just I'm magnifying it. Okay, so I'm just doing a little bit zoom in for this, and we can see that see, in each bigger divisions we have 5 divisions. Okay, and this is 0, next bigger division is 10, and the next bigger division is 20. So in between two bigger divisions we have 5 divisions, 5 small divisions. So it means that the least count of this will be one division equal to 2 joules. Okay, so fine. Now this part, this lever which we can see, this is known as the brake lever. Okay, by this lever we will apply the brake. Okay, and while performing the test we will see that what is the significance of this and how to apply the brake in this particular machine. Right, now this one, this rod and this complete part is known as the hammer part. Okay, this is the hammer of this machine, and this is known as the lever arm. Okay, and as we can see that this hammer is temporarily attached with this lever arm with the help of this lever. Okay, if you move this lever or release this lever, whatever, okay, then what will happen, that suddenly this hammer will release and it will strike the specimen with some impact. Okay, and one more thing is there, a specific type of striker is there which is attached with this. You can see from here, this is a rectangular striker. It is in the form of in the shape of a rectangle. So in Izod test we use rectangular striker, and in case of Charpy we used the triangular striker. Fine. So as of now we have saw the impact testing machine. Now the next thing is, first of all, what we'll do, that we will see the loss of energy due to friction. Okay, and how to see the loss of energy due to friction? What we'll do, that initially we will not put the specimen into the machine. Okay, will not fix the specimen into the machine. Why we are not fixing the specimen into the machine? Because as we know that the moment I release this lever, this hammer will strike it. Okay, and if there is no specimen, then whatever the loss of the energy due to friction will be there, it will be shown by this by this dial indicator. Okay, fine. So now I am going to release this lever. You can see. Okay, so as this is a very very dangerous machine, so we have to take utmost precautions, and this particular part of this machine is just for the precaution that we have to keep ourselves a stay back. Okay, now see, I am going to release this lever. Okay, fine. As we can see that there is no specimen as of now, but still it is showing some energy loss due to friction. Okay, now we'll see the significance of this brake lever. Okay, now see how to apply the brake. The brake will apply when this hammer will go from this part to this side. Okay, see, so we'll apply the brake in the, when the lever will go in the two direction, not in the fro direction. Okay, fine. So as of now we have performed the the initial part, in which we need to find the loss of energy due to friction. Now we'll again attach this hammer with this key and we'll fix the specimen. So first this one. Please bring it. Okay. Fine. So as of now, we have seen already that the loss of energy due to friction was 40 joule. Okay. So the initial loss of energy due to friction is 40 joule. Okay. Now this time we have fixed the specimen in the machine, and when we will release this lever, this striker or this hammer will hit this specimen and it will break into two different parts, and again we will see the next energy, energy loss in the transit. Okay, initially what we had found, the energy loss in the friction, the energy loss due to friction, and this time we will see the energy loss in the transit of this hammer. Okay, and the final strength of this material, final toughness of this material, actually we used to calculate or we used to find the toughness of the specimen in the impact testing machine. So the total toughness of this material will be equal to the energy loss in transit minus energy loss in friction. Okay, now fine, as we can see here, this specimen, we have fixed this specimen in the form of a vertical cantilever. Okay, and there is a notch here. Why we used to put this notch? Just to concentrate the stress. Okay, this is for the stress concentration actually. Okay, so that the stress should get concentrated at this particular area, or you can call it as the crack tip. Okay, so how we used to put this specimen in this machine, like the vertical cantilever, means the bottom part of this specimen will be fixed and the upper part will be free. Fine. Now after this, we are going to release this lever. The moment I will release this lever, this hammer will hit this hammer will strike the specimen with impact. Right, now we can see it, and again I'll make some distance. Fine. Now again I'll apply the brakes to stop it. Okay, in the two direction, not in the flow direction. Two direction means when it goes from left to right. Okay, fine. So this time, okay, I'll put this camera just above the needle. It's coming around 70 joules. Okay, so 70 joules is the energy loss in the transit of the hammer when the specimen was there. Okay, so final we can call it as the total strength of this material, total impact strength of this particular material will be equal to 70 minus 40 equal to 30 joules. That's all. Okay.